Good morning, dear students. Today we are going to see from the second volume, Chemistry, unit number 8. The topic is Ionic Equilibrium. This is the first lesson in second volume. So let us see. Peter Joseph William Debye. He got Nobel Prize for the chemistry. So how he has done, let us see. He is a Dutch American. He is a physics, greatly contributed to the theory of electrolyte solutions. He also studied the dipole moments of the molecules. You know, all the molecules have some positive and negative ends in their molecular structure. So therefore they exhibit dipoles, positive and negative poles. So Debye won the Nobel Prize in Chemistry for the contributions to the determination of molecular structure through his investigations on dipole moments and X-ray diffraction. So on these two things he defined the structure of the molecules. What are the learning objectives of this particular lesson? There are so many learning objectives, but in this particular video class we are going to see only the first one. After studying this unit, the students will be able to, first one, classify the substances into acids and bases based on one Mr. Arrhenius, second Lowry and Bronsted theory, and the third one Lewis concept. So on these three scientist concepts we are going to classify acids and bases. This is our main objective of this particular video, and the remaining all the objectives we will see in the next videos. Introduction. Already we have studied in 11th standard in this chemical equilibrium lesson, but here we are going to discuss ionic equilibrium, especially acid base equilibrium. You know what I mean by neutralization reaction. When an acid reacts with the base, gives us salt and water. This is known as neutralization reaction. Here we are going to see the acid base equilibrium. Some of the important processes in this body involve aqueous equilibrium. So inside our body there are so many reactions taking place. For example, carbonic acid, bicarbonate buffer in the blood. So this is the reaction which takes place in the blood. See the equation, H3O plus. H3O plus means hydronium ion, that is a water molecule plus one H plus. So hydronium ion plus HCO3 carbonate. These two things gives H2CO3 plus H2O. So we have come across many chemical compounds in our daily life. Among them are so many acids and bases. Most common, for example, in milk you have lactic acid, vinegar you have acetic acid, tea, drinking tea you have tannic acid, and in the antacid table, so when you have some fire feeling inside the stomach, we are using some tablets known as antacid tablets. For example, Gerusil you can use. So these tablets contain aluminum hydroxide and magnesium hydroxide. And we also know some other acids present. For example, in grapes you have tartaric acid, in lemon you have citric acid. Like that we have studied in so many lessons also. So the next one, this acid and bases have many important industrial applications. So for example, sulfuric acid is used in the fertilizer industry for preparing all sulfates, and sodium hydroxide is used in the soap industry. We are using both detergents and soaps for bathing. These soaps we have hydroxides. sodium hydroxide and potassium hydroxide, which is used in the soap industry. So hence it is important to understand the properties of acids and bases. So daily life we are using so many things which contains acids and bases. In this unit we shall learn the definitions of acids and bases and study their ionization in aqueous solution, and also we are going to study about the pH scale, how to apply them, what are the principles. So that also we can study in this particular lesson. 8.1, that is acids and bases. From where we get it word acid? Acid is derived from the Latin word acidus, meaning sour. In Tamil we are used to say pulippu suvai. So sour taste. So after all having sour taste, they contain acid. We have already learnt in this earlier classes. So what happens to the acid? Acid taste sour turns blue litmus to red litmus. So the opposite is for the base. What will happen to the base? Base is having bitter taste and turns red litmus to blue. So these classification concepts are adequate to explain the complete behavior of acids and bases. So we have developed some acid base concept theory. The first one, Arrhenius, and the second one, Bronsted and Lowry, and the third one, Lewis. So all these concepts we are going to see. Let us see the first one, that is Arrhenius concept. What he is telling. One of the earliest theories about the acids and bases. So proposed by this Swedish chemist Svante Arrhenius. According to him, an acid is a substance that dissociates to give hydrogen ions in water. That is, when the substance is kept in water in dilution, it dissociates into H plus ion. So hydrogen ion it gives. So dissociation in the aqueous solution is given down. See the equation, HCl, which is in gaseous state, when it is dissolved in water, H2O, it gives H plus, which is also in aqueous solution, plus Cl minus, which is also in aqueous condition. So in this equation we got H plus as the product. So it is an equilibrium reaction. Both forward and reversible reaction takes place. In this, the H plus ion in the aqueous solution is highly hydrated and usually represented as H3O plus. So instead of H plus, we can use H3O plus also. The name is hydronium. H3O plus is known as hydronium ion. So in the simplest hydrate of proton, what we are going to write down now, H3O plus can be written as H2O. The whole bracket you put square bracket and then put plus over there. We use both H plus and H3O plus to mean the same. Any one we can use. Either we can use H plus or we can use H3O plus also. Both the ions are one and the same. Similarly, what is a base? Base is a substance which dissociates to give hydroxyl ion, that is a OH minus ion. Whenever a substance is dissolved in water, if it gives OH minus ion, then it is known as a base. For example, substances like NaOH, calcium hydroxide, etc. are bases. The example given here is calcium hydroxide, CaOH twice. When it is dissolved in water, it gives Ca2 plus and 2 OH minus. Since it gives OH minus, this is a base. Calcium hydroxide is a base. So there are some limitations of the Arrhenius concept. What is the limitation? Though this Arrhenius theory explains very clearly about the acid and bases, it does not explain the behavior of acids and bases in non-aqueous solution. When there is no water, when it is dry, the Arrhenius theory cannot be explained. For example, acetone, tetrahydrofuran. So whether they are acids or bases, that cannot be explained by Arrhenius theory. This theory does not account for the basicity of the substances like ammonia NH3, which do not possess OH minus ion. Hydroxyl ion group is not there, but it acts as a base. So how to explain this one? So these explanations are not given by Arrhenius concept. One evaluation is given down. Classify following as acid or bases using Arrhenius concept. We know that whatever is giving H plus is known as hydrogen ion. Concentration means acid, and OH minus means then it is a base. Okay. So the first one, HNO3, nitric acid, because it gives H plus ion. The second one, BaOH twice. So here it acts as a base because it gives out OH minus ion. And the third one, H3PO4, that is orthophosphoric acid, its name. It also gives H ions. So that is also acting as acid. The last one, CH3COOH. Since COOH is there, you should not take it as a base. It is an acid. This is acetic acid, which gives out only the H plus ion, CH3COO minus and H plus. This is the way in which it dissociates. Therefore, when it gives H plus, this becomes an acid. So in this case, in this example, all the three are acids except BaOH twice, which is a base. Now this is what we have studied regarding Arrhenius theory. Then now let us go to the Lowry-Bronsted theory, that is proton theory. So Lowry-Bronsted suggested in 1923 a more general discussion of acids and bases. According to their concept, an acid defined as a, remember, the substance that has a tendency to donate a proton. Proton means H plus ion to another substance. And what is a base? Base is a substance that has a tendency to accept a proton, that is, receives a proton from other substances. So these two things are known as acids and bases. Please underline this. This is the definition for acid and bases according to Lowry-Bronsted. So acid is a proton donor and base is a proton acceptor. When hydrogen chloride is dissolved in water, one example, HCl plus H2O is given. It is in equilibrium with H3O plus, that is hydronium ion. The water receives H plus ions from HCl and it becomes H3O plus and plus Cl minus ion is there. So similarly, ammonia, when it dissolved in water, so ammonia becomes ammonium NH4. H2O plus NH3 gives NH4 ammonium plus OH minus hydroxyl ion. So let us consider the reverse reaction of the following equilibrium. For example, HCl plus water gives hydronium ion plus Cl minus ion. So in this case, HCl is an acid because it donates a proton, so proton donor. H2O, it accepts a proton, that is, it accepts only H plus, therefore it becomes H3O plus. Therefore H2O is a proton acceptor which acts as a base. If you see on the right hand side, H3O plus, proton donor, it is ready to donate a proton, therefore it is an acid. And finally Cl minus, proton acceptor because it is ready to accept a proton, so it acts as a base. So these things are given according to Lowry-Bronsted theory. In this theory, the acid base reaction is represented as acid 1 base 2 gives acid 2 plus base 1. So the acid 1 and base 1 are known as conjugate acid and conjugate base. Similarly, base 2 and acid 2 are known as conjugate acids and bases. Those are the species that remains after the donation of a proton is a base, and is called as a conjugate base of the Bronsted acid. In other words, chemical species that differ only by a proton are called conjugate acid. So, see that equation. HCl water gives H3O plus and Cl minus. In this, the left hand side HCl is known as proton donor and its corresponding conjugate base is Cl minus. Similarly, H2O proton acceptor, it's a base, its conjugate acid is H3O plus, that is proton donor. So, this is the conjugate acid base pair given by the Lowry-Bronsted. So, limitations of this theory. Substances like Lowry-Bronsted, substances like BF3, boron trifluoride, AlCl3, aluminum trichloride, etc., they do not donate protons, but they are known as acids. So, how? This explanation is not given by Lowry-Bronsted theories. So, there are some evaluation is given for yourself to do. Please go through what are they, whether they are acid or bases, which is given down there. Sulfuric acid, acetic acid and ammonium is given. You find out, apply this Lowry-Bronsted theory. And then we are coming to the third theory, that is Lewis concept. This Lewis concept, it is proposed by Gilbert N. Lewis in 1923, a more generalized concept of acids and bases. He considered the electron pair to define a species, whether it is an acid or a base. According to him, an acid, please note it down, an acid is a species that accepts an electron pair, while base is a species that donates an electron pair. We call such species as Lewis bases and Lewis acids. We have to mention this Lewis acid and Lewis bases for this particular compounds. A Lewis acid is a positive ion or an electron deficient molecule, and Lewis base is an anion, a neutral molecule with at least one lone pair of electrons ready to donate. It should be ready to donate. See the example down, boron trifluoride, and right side it is given as ammonia NH3. There are two electrons in the outermost shell, a pair of electron which is free. It is not bonded, it is free. Therefore, ammonia is ready to donate these pair of electrons to the boron trifluoride boron and forms a bond which is known as coordinate covalent bond. See on the right side, from nitrogen an electron donated to the boron, so the arrow mark bond is given there, coordinate bond. Both the electrons are donated from one atom. So, in this, the first one is electron deficient boron trifluoride. Since it is an electron deficient, it is known as Lewis acid. And electron donor, a pair of electron is donated by ammonia, this is known as Lewis base. So, boron has a vacant 2p orbital. Boron electronic configuration is 1s2, 2s2, 2p, 1 only. So, in 2p we have vacant orbitals. So, it is a donate a pair of electron from nitrogen can be accommodated. So, we have already learned that in coordination compound, what is a ligand? Ligand is an electron pair donor to the central metal atom which accepts a pair of electron. So, according to this, the Lewis concept, ligand behaves as a Lewis acid. The next. So, what is the difference between Lewis acids and Lewis bases? First one, electron deficient molecules. Lewis acids are electron deficient molecules. For example, BF3, boron trifluoride. Always you remember boron trifluoride, which gets a pair of electron from ammonia. So, on the other side, Lewis bases which are having a lone pair of electron. For the first best example is ammonia is given NH3, H2O, ROH is alcohol, ROR is ether, RNH2 is amine, primary amine. The second point, all metal ions, example Fe2 plus Fe3 plus Cr3 plus Cu2 plus etc. They are all Lewis acids. And all anions, F minus, Cl minus, Cn minus, Cn minus, SO4, 2 minus, all these things minus are Lewis bases. Molecules that contain a polar double bond, examples, they are acids, SO2, CO2, SO3, etc. because they have double bonds. And what are the Lewis bases? Molecules that contain carbon-carbon multiple bond, that is unsaturated, example CH2 double bond CH2, CH triple bond CH, that is acetylene. So all these things are considered as Lewis bases because they are all ready to donate a pair of electrons. And then molecules in which the central atom can expand its octet due to the availability of the empty d orbitals, example SiF4, SF4, FeCl3. On the right hand side, for Lewis bases, all metal oxides, that is calcium oxide, magnesium oxide and sodium oxide, they are all considered as Lewis bases. And Lewis acid, carbonium ion, that is positive ion, CH3 thrice C plus. And Lewis bases, it should be negative, carbanion, that is carbanion, CH3 minus. So how to measure the strength of the acids and bases? The acids and bases, the strength can be determined by the concentration of hydrogen ion, that is H plus or otherwise H3O plus ion concentration, which gives you acid. OH minus ion concentration, which gives you the base, produced by the mole substance dissolved in water. So generally we classify the acids and bases either a strong or weak acid. We used to call some of the acids as strong and some other as the weak. How? So let us define this quantitatively. Consider the following equation. Ha plus H2O gives H3O plus and A minus. In this case, the first one is acid because it gives out a proton Ha, which gives out own H plus ion, therefore it becomes an acid. Then H2O, water, it receives that H plus from the Ha, therefore it becomes an H3O plus, which is an acid, and A minus is a base one. So according to Laurie-Bronston theory, that conjugate acids and bases. If we have to find out the equilibrium constant K, the concentration of the product of the equation, that is H3O plus and A minus, these two concentrations you have to multiply divided by concentration of the reactants, that is HA and H2O concentrations. Since water concentration is always large when it is water is a excess, that can be avoided, the concentration can be avoided, water concentration. Therefore the equation becomes Ka is equal to H3O plus into A minus divided by HA only, no water molecule. Okay. So here this Ka is called the ionization constant or dissociation constant of the acid. Ka means dissociation constant of the acid. It measures the strength of the acid. So acids such as hydrochloric, nitric acid, sulfuric acid, etc. These acids are completely ionized, that is HCl, when it is dissolved in water, it completely dissociates into H plus and Cl minus. Therefore this is a strong acid. In this acid, the completely ionized, they have a high Ka value, The Ka value for HCl is given as 2 into 10 power 6 at 25 degrees Celsius, that is normal room temperature. The Ka value of HCl is given as 2 into 10 power 6. Therefore, it is considered as strong acid. In case of acetic acid or formic acid, it is 1.8 into 10 power minus 5 at 25 degrees Celsius. Therefore, it is considered as a weak acid because the acid is partially ionized. Only few molecules are ionized and the remaining are as it is. So, this is the way in which they are called as strong and weak acids. Earlier, we have discussed that is complete dissociation of the equilibrium, almost 100%. The Cl minus ion has only a negligible tendency to accept a proton, form H3O plus. So, it means that the conjugate base and the strong acid is a weak base and vice versa. The following table explains about the strength of the acids and bases. So, what are all strong acids, weak acids and very weak acids? Similarly, very weak bases and weak bases and strong bases are given. You just please go through. HClO4 is strong acid, HNO3 is also a strong acid, H3O plus is a weak acid. Similarly, acetic acid is also a weak acid. Ammonia is very weak acid. Ionization of water. So, water molecule, how it dissociates? See the equation. The first one, water molecule HO and H is given. The second water molecule is H2O is given. The hydrogen from the first water molecule goes to the second water molecule. Therefore, the second water molecule becomes H3O plus and the first water molecule becomes only OH minus. So, two water molecules combine together and gives out one H3O plus hydronium ion and OH minus. So, here also we are applying that conjugate acid base pair. In the above ionization, one water molecule acts as an acid while the other water molecule acts as a base. So, what is the dissociation constant for this one? So, concentration product multiplication of the products K is equal to H3O plus into OH minus ion concentration divided by H2O concentration power 2, because we have two water molecules in the reactant side. Since the concentration of the pure water is considered as 1, so the denominator becomes 1. Therefore, Kw is equal to H3O plus and OH minus ion. This Kw represents the ionic product. The ionic product of water is represented by Kw, which is nothing but concentration of hydronium ion into concentration of the hydroxyl ion. It was experimentally found that the concentration of H3O plus in pure water is 1 into 10 power minus 7. Similarly, the concentration of OH minus is also equal to 1 into 10 power minus 7 when the temperature is at 25 degrees Celsius. So, this is known as ionic product of water. So, Kw is equal to H3O plus and OH minus ion. So, Kw value, so H3O plus is also 1 into 10 power minus 7, OH minus is also 1 into 10 power minus 7, therefore, you are getting 1 into 10 power minus 14. So, Kw is also a constant at particular temperature, that is 25 degrees Celsius. The dissociation of water is an endothermic reaction. What do you mean by endothermic? Exothermic means evolution of heat. Endothermic means absorption of the heat. So, it absorbs the heat. With increase in temperature, the concentration of H3O plus and OH minus increases and hence the ionic product also increases. So, in the tabular column, they have given the temperature and ionic product also. So, water is the 0 degree Celsius means the ionic product is 1 into 1.4 into 10 power minus 15. So similarly, different values of the ionic products are given in the tabular column. So from this we can understand, and considering the aqueous solution of HCl as an example, in addition to the auto ionization of water, the following equilibrium due to the dissociation of HCl can also exist. So HCl plus water molecules gives hydronium ion plus Cl chloride ion. In this case, addition to the auto ionization of water, HCl molecules also produces H3O plus ions, donating a proton to the water, and hence the concentration of H3O plus is always greater than OH minus. It means that the aqueous HCl solution is always acidic. Similarly, you consider for the basic in the opposite direction. For basic, we have compounds such as ammonia NH3, NaOH. In this case, the concentration of OH minus ion is more than H3O plus, therefore they are basic in nature. So with that, this lesson is over. Dear students, we have given 4 questions for assignment. Please go through this and answer all those things in your notebook. Thank you very much. Best wishes.